Okay. Recording now. Okay. All right. So shall we start?
Yeah.
Okay. So thank you, the Science Club, for having us today, and I want to thank
AI Club.
AI Club.
Yeah.
All right. I mean, it's close enough, I guess. Yeah. All right. So thank you for having us today, and I want to thank you specifically for coming this late at night. Which is going to be a good opportunity for you to see something that might be a little bit different from what you're familiar with. So this is Mohammed, software engineering. I'm going to talk to you about this work that we have been doing with JetBrains specifically into how we can improve the extract method refactoring in IntelliJ, right? This is the main topic about today. But one thing that I will try to also emphasize here is the importance of motivating your problem, right? You're all going to go one day and you'll be talking with many people, that may or may not understand the bottom of what you're doing, right? But they can see whether it's actually worth doing or not. And you have to be able to convey that message to them, okay? So therefore, you will see me talk a lot about the problem more than the solution. Because if you sell the problem, you sell your solution as well. Okay, so this is something that I will try to overemphasize here today, is how you can really motivate your audience to better understand what you're doing and make them really excited about it, okay? So and this is going to be a tutorial again. Good news is this is for people who don't know refactoring, so it's an opportunity for you to learn what refactoring means, okay? And then I'll talk about the challenges of refactoring, and I'll give you an example of why refactoring is so important, right? And we can go from a problem, solution, and then implementation. So I'll talk about the problem, a little bit of the solution. Lee will have you also talk about the more details of the solution than the implementation, right? So also this presentation will tell you what's research, right? If you're really asking this question, so how do we do research, right? So this could be really a good example of how a research idea can be born, and then how it can become mature, and how it can become a concrete product, okay? So this can also help you with that point. So this is all started when one of my students was saying, back when he was at Xerox, right now he's at Microsoft, he came to me one day and he said that, I noticed that my pull requests, when they are about refactoring, they took longer to be accepted, right? To have a decision made, right? And he came to me and said that because I'm a refactoring guy, he wanted to trigger me, right? And it's true that I was surprised. Why? Because refactoring by definition is the art of improving the code structure, how it's written, without changing its behavior. So it's what we call code cleaning, right? Code cleanup, right? Improving your code, right? You would expect this to be easier to be passing through the code review versus something that is not a refactoring, right? You would expect that, okay, if I'm a code reviewer and I see that people are trying to clean up the code or help improve the code, I would accept this faster. He was telling me that it's not the case. It actually takes even longer to be approved. And that, of course, triggers my curiosity. And I'm like, I have to double check whether this is true or not. So what we have done is we went to Xerox and said, hey, give us access to your pull request. They said, no. I said, hey, you have a problem there. I want to figure that out. Can you please help us help your own developers? I said, okay, then let's think about it. After a few backs and forth and signing some NDAs and everything, they gave us access to some of their information. So we were able to go and find and locate on that year 171 refactoring pull requests. These are code changes that are submitted for the purpose of improving the quality of the code, renames, extracts, moving stuff around, cleaning up the code, etc. We knew who did those changes in their repository, developers, and we also selected 171 non-refactoring pull requests like bug fixes or feature updates that are also from the same authors, right? Around the same time, okay? I'm trying here to compare apples to apples, okay? So now we have 171 refactoring pull requests versus 171 non-refactoring pull requests. I want to see now which one takes longer to be made decision, either they approved or denied, and how long it takes between these code authors and code reviewers to get this through. This now the investigation, right? So this is what we call an empirical, comparison. And so this is an empirical setup to see, to come up, I have a hypothesis, and I want to evaluate whether this hypothesis is correct or not, right? So this is my hypothesis, right? This one, which is for saying that the refactoring code review takes longer than non-refactoring code review. I'm like, all right, let me then see whether this is true or not. And what we have found is as follows. So this is the review duration of refactoring review versus non-refactoring review. And indeed, as you can see here, refactoring code reviews take longer to be completed than refactoring non-refactoring code reviews. Over those 171 examples, so the difference, and also we found the difference is statistically significant. Okay, so it's actually takes longer. Same thing with discussion as here. Also, the number of back and forth discussions on their own. I don't know whether they have Slack or whatever they have. It's not the Slack, it's like GitHub, but they have their own discussion between, if you see a pull request and you see how reviewers will discuss with code authors the changes and everything. So it typically takes longer or triggers longer discussions between the code authors and reviewers before they can make a decision. Okay, so this shows that yes, we do have a problem here. And when we went and we saw how reviewers or how code authors document their refactoring, we realized that it's kind of one of the problems there. So we recommended for Xerox developers, when they are writing refactoring pull requests from now on, to keep an eye on three things, 3 I's, we call them. The first I is the intent. When you are writing, when you are documenting your refactoring pull request, make sure to mention the what. What are you doing with this refactoring? Are you removing some dead code? Are you, refactoring duplicate methods? What are you splitting a class? What are you doing exactly? Let the reviewers know what are you doing. The second I is how you are doing that. You are renaming stuff. Are you splitting? Are you extracting? Are you inlining? What kind of operation are you performing so they can see that in the source code better? Okay. And finally, tell me, how do I measure that what you have done is fine? Okay. Is this change going to, so it's the impact, right? So are you going to improve readability? Are you trying to help with coupling, reduce coupling? Are you improving cohesion? What are you doing exactly, right? So if you kind of tell them, what's the purpose, tell them how you're doing it, and what the impact on the source code, you are giving them measures and ways to measure and evaluate your own code change better. Because those were actually the questions that we saw from the reviewers. Why are you doing it? Why this is happening, right? Why, right? How do I measure it? How do I know this is fine, right? So if you kind of tell them this through the documentation, this can help them, maybe make a decision faster and accept faster your refactoring, right? Is this the end of the story? I wish, right? So this is a picture of a railroad, as you can see here. And if you have been to Europe, anyone have been to Europe, you'll see this a lot, especially in France, right? Anyone speaks French here by any chance? You do? You can read this, you think? Can hide. Yeah, caché, yeah, hide. So it's perfect. Awesome, man. Awesome. This is good. A quick quiz on French, right? So yeah, this is says un peu en caché. So a train may hide another one. Which means here that this misunderstanding of refactoring is actually, or in documentation, is hiding a way bigger problem, right? And this problem has been already found and triggered by many previous studies. That they talk about how refactoring is being misused by developers, whether people trust refactoring or not, confessions of refactoring as if it's a sin, right? And it's various things that talk about problems, barriers of successful refactoring. So there's a lot of problems with refactoring, right? If I'm trying to summarize what these papers are saying, they're saying that refactoring tools are underused. People are still wanting to do things manually. If I have a method I want to rename, I'll do it just manually. If I want to split a class, I will just copy paste it and try to remove instructions. I'll do things manually and would not trust anything that is doing this for me automatically. Okay, and obviously we have seen an example of how refactoring documentation is not well formalized. Do we teach us how to do that? No. Do we teach us here even how to refactor code properly? Maybe. Lee has taken my class. He knows I do that, but not in many other disciplines, right? We don't learn how to do refactoring, even though we will be doing this. We have been doing this already, and we'll be doing this all the time in the future. But that's something we learn on the fly. Okay. So we do have actually a lack of refactoring culture, indeed. Okay. Even though it is extremely important for Q&A. We know that, but we don't learn it. Okay. So one of those papers that talk about the confessions, that we found that indeed developers do apply some refactoring, and the most popular IDE that is kind of successfully having people refactor through their IDE is actually IntelliJ, okay, which is this one, right? So therefore we decided, RIT, some folks from software engineering, then some JetBrains research guys to kind of put forces together and discuss and understand how usability, what is challenging developers to actually use the IDE to refactor their code. Okay, so this is the question, like, if you have an IDE which can help you refactor code, why don't you just use that? Why are we still using our intuitive manual refactoring versus using a whole feature that is implemented through the IDE? And this can apply to C#, like VS Studio or anything else, right? Same thing. Because if you do it manually, you do it manually everywhere you go. Okay. So we wrote this long survey for developers that are using IntelliJ. Anyway, so this is just basically what we were asking here is how do you refactor code? As simple as that. Okay. And what we have found, and the people that were responding are actually developers. So we have some of them, they have a lot of experience. So we're talking about people who are really into coding for a long time. And what we have found is this. This is what we have found. So these are, we clustered refactoring by 3 categories. Either it's a rename, you're renaming a class or a method or a package, versus you are extracting a method, this is splitting a method, right? Or you are merging 2 methods together, and this is the extraction. And you have moving stuff, either you're moving a class into a different package or moving a method into a different class, etc. So these are the 3 different categories. Either you rename, extract, or move. Okay, so for the rename, we noticed that 80% or 85% of people actually rename their code through the IDE. Okay, and one of the reasons why we figured that out is because the shortcut, the keyboard shortcut that they have in IntelliJ is so smooth and so useful that people we can rename that very easily, right? But unfortunately, it's not. So rename is fine. People are still using the IDE when they rename the code. And this is good news because when you are using the IDE to do that, you are guaranteed that you would not break the code. This is our problem, by the way, with manual refactoring. Because if you don't use the IDE to refactor your code, you may actually break it. You make your code more prone to errors. Okay. So if you rename through the IDE, you are guaranteed that you did not, for example, have a duplicate name here and there, etc. Right? So therefore, this is fine. People are using the IntelliJ rename to do their renames. Unfortunately, it's not as popular as for extract and move. As you can see, only half of people here, they use the extract method feature. And the remaining what they do this manually. Either they replace and find or copy and paste or just do pure manual stuff, right? So they don't really use the IDE for that. So this becomes, for us, this is alarming. It's a problem, right? It's not that popular, and this is a problem. Yet extract is not an easy refactoring, though. If you want to split something into 2, you will have, the copy and paste, you would copy and paste the method. Then you have now 2 methods with the same name. You have to rename one of them, sort of, and then you have to go and remove some instructions here and keep some and move some other instructions here. It's a dirty work, right? And doing this through manual copy and paste is actually painful. But people do that still, okay? Even though you would expect this to be easier for move, actually it's not the case. Copy and paste is still the popular action when you are moving stuff. It will be more likely cut and paste in this case, right? So So it's even worse for move, right? So this is what we have found. And actually, when we discuss with these developers, it's true they say it's because it's intuitive to just use manually. Why would I need to do this with the ID? They don't see the reason to do that, right? They don't realize that they are making mistakes when they do that, right? And also they think that they didn't even know that IntelliJ has those implemented. They didn't know that. So we don't know as well. Or I didn't think about it at the time. It's not one of my practices, again. And also, I don't know whether it would work the way I want or not, okay? So it's really a problem of refactoring culture that we can see here, okay? Unfortunately, I mean, all these things can be just solved if we start clicking on this menu and looking at those options because they're there. And it's true, we don't really use them, right? You have all these features, rename, extract, move, they're here. Is that menu on your IntelliJ or PyCharm that you never truly click on anyway? Okay, so we do have a problem with this menu. This is our takeaway, that students, developers, we don't use this menu. Or maybe we use other menus more carefully, but this one, the way it is set up, is not helping us at all. So that's our recommendation too, is this menu is not going to be helping at all. So we have to find another way for us to motivate developers to refactor their code rather than asking them to click on this menu. Okay, this is how you find a problem, right? When you're doing research and when you're looking at those data, this is how we can come up with a problem, right? This is where I start thinking about, okay, how do we do this? How do we come up with a more intuitive way to ask developers to refactor code without telling them, hey, go when you need to do rename, please click on this. When you need to do move, please click on this. We have to find another way to make that happen, right? So this is the studies that we have done that have shown these problems. And it's not clicking here. And we wanted to start with someplace, right? We want to come up with a way. We were to look at these problems and think which one we should start solving first, right? The rename here is fine. Okay, 85% is okay. We don't want to go and try to improve that. We have the extract and the move are problematic. So where do we start? Which one should we tackle first so that we can help developers improve their refactoring? If you were at this stage, what would you do? Let me put you here in the spot. What do you think we should do here? I'm just giving you a problem here. You know, people are not using that menu, and we have a lot of manual stuff is being done. So what should we do? Where do we start?
SSE had some answers, you guys.
No, they let them think. I mean, they need to think about it, honestly. It's what would you do? Because this is where we can get new ideas, right?
Yeah.
What would you do? We had an idea and we did something, right? So what would you do? Where do you think we should start? And how do we do that?
You mentioned the example of having very easy to do like key combination.
Yeah.
Do like the name. So it seems like try to do something similar to that.
Okay. But when you're moving, actually, you're cutting and pasting code, right? So how would their shortcut help with that? Like, you highlight the code, then you click on this shortcut that would tell you that you're doing. Yeah, that might be a good idea, actually. All right, yeah, that could be a good idea. Starting with that would be good. Like highlighting code and deciding that this has to be either copy pasted or moved, right? So that would be something that is worth maybe investigating for sure. Shortcuts. Maybe they even have shortcuts for that. I don't know. So the way we thought about this was we looked at what is the most manual action that people are taking when they do this, right? And if you pay more closer attention, the action that we don't want people to do, but they're doing most likely or all the time is this. So this copy and paste, right, is contributing to all of these things, right? And it's, if you just sum up this column, right? It's a column, yeah. If you sum up this column, right, you'll notice it's the highest taken action among all the other actions, right? So if we can help developers with better copy pasting code, then we can win in all cases, right? So we will have those numbers go down, right? We want to go, we'll have those numbers go down, which means then when they copy and paste, for example, for the purpose of moving stuff, right? We have to take an action in that moment. But we typically copy and paste not for the purpose of move, but for the purpose of what? I say about copy and paste, right? When do we do that? And we do that all the time, by the way. When do you guys copy and paste code? When you're exactly when you are reusing code, exactly. And that's not called laziness, that's called code reuse. Some people call that plagiarism. Some other people call that, laziness. That's software engineering. You copy and paste, that's software engineering. That's software reuse. Guess what? We do that all the time. Look, those are expert developers. And they are copy pasting code. It is what it is, right? So if we can help them with that, we win. If we can make that better, right? If when someone is copy pasting and when we detect that and we say, hey, do this way, it will be better, okay? So code reuse is trivial, it's intuitive. We all do that. I need this feature here. I know how to do it. I've done that before. Why would I write this again? I'll just copy and paste. As simple as that, right? We all do that. But what's the problem with that? We do have one problem though. When you're copy pasting the same piece of code multiple times, what's the problem with that? That's a response to what? Yeah, it means don't do it, right? But what's the problem with copy pasting code? You're propagating an error. That's a typical example. Perfect. What else? Yeah, it has many problems. What else? When you copy pasting code, you might propagate errors. That's true. What else?
Do you ever want to change that behavior?
Thank you. And guess what? Most of the time you're working on a code that is not yours. So whoever comes later doesn't know about that copy paste anymore. So when you change that fragment, you forget that this fragment has been copy pasted. You may forget, you may even don't know because someone else did that in the code. And now you have the same, supposedly the same logic, but it's not the same way it's written anymore, right? And this also triggers a lot of errors in code. Okay, and then he comes and says, who did that, right? So why this is this way, right? So it's a typical problem when you have the same logic written multiple times. And therefore, a response to that would be to do what? If you have the same logic, the same code fragment, repeated multiple times, what would you do to fix that? Put it into one method, right? If you have this code written here, here, and here, I would take this code, put it into a method, and then call this method here, and here, and here. We call that extract method refactor. So whenever you have duplicate code, which is fine, I need this feature here, and here, and here, right? I can just take this code fragment that I'm duplicating, have it into a method, then call this method multiple times, and I win. Is that clear? Any questions? So if whenever someone copy pasting the same piece of code, and I can know that, I can detect that, okay, this person is copy pasting this code multiple times, whatever reason, that's fine. If I can tell them, hey, do you want to have this into a method? Right? proactively tell them immediately, hey, have this into a method and have it here instead, right? Maybe this is the better way of applying that extract method refactoring, which, by the way, it exists here, right? Instead of me expecting that person to copy paste code multiple times, then go and click on extract, I can tell them, hey, extract this right away. That was the idea that was born kind of as a response to this problem. Okay, so duplicate code again is the action of having, right? Code having of, code snippets copy pasted multiple times. It might be in different files or the same file, different functions or different locations. So yeah, whatever it is, it's a copy paste. It's called a copy paste, right? And this is such a famous action that you may think, but this is, why would I even care? Why do we even care about copy paste? Actually, we do care about it a lot, to the level of flagging it as a bad practice, as a code smell, it's a bad practice. So people will not let you do that. If you go to a company like Xerox or Microsoft and you copy paste code, they will say, no, don't do that. Okay. And also we have a lot of principles, design principles that tell you do not duplicate that piece of code. Okay. Don't repeat yourself. Principle, right? However, is this efficient? Is it just okay? Is it working that we are asking people not to do it? Actually, with this result, right, it's not working. People are still copy pasting code because it's called reuse. Okay. So therefore, we have a whole conference. People come from all over the world to discuss how we can help people do better than just copy pasting code. We call this the International Workshop on Software Clones. Okay, because it's such an intuitive action that we should no longer ask people not to do it, but instead let's find a way to make that even a better practice. Okay, and this happened actually last month, right? October 2nd, we're almost there. So it's almost less than a month away that this happened, right? And it happened in a good place, obviously, not here. Somewhere that we should all be there anyway. That's why you should like code clones. And this event, they had a keynote. Okay, on that keynote, this is one of the professors who was actively working to improve, or to help with code clones. And she was talking about this in her keynote. She said that they looked at 2 million non-fork projects on GitHub. So these are all like legit projects on GitHub, right? And they looked at over 258 million files, right? And they found a larger amount of duplication, much more than they expected. And these are the clone guys, right? I mean, they're the people who look at clones all the time. And then when they looked at all these projects, they found a very large ratio of clones. So things are going even worse than they thought. Okay. And something interesting they mentioned, which is of an interest to you guys, right? They said this is going to be a problem for people who do machine learning. That's what they say, right? And the question is why? Code clones and machine learning? What's the problem? What's the link? Why the AI folks have to be worried about this? What's the link? Code clones and machine learning. What's the link here? She didn't say this is a problem for developers. This is a problem for data scientists also.
Models and stuff, if they look at the duplication of the data, then I guess I have to duplicate this data.
Code for data scientists and machine learning people is data. What do you have? Do you have guys problem with data when it's duplicated? Of course, it's data leakage, right? What is going to happen is you will come and start with the rise of language models, right? You know of them, and they're big right now, right? If you use this data to train and test, you're linking data between training and testing. No, I'm not doing that. I'm copy pasting. I'm using these projects for training, and these are for testing. There is no way in how they have duplicates. Guess what? Yes, they do. And there is no way for you to figure that out. This is why it's going to be a threat for machine learning. Okay, so it's a problem because all the big companies, Microsoft, Google, all of them are training their new models into this piece of these codes, right? So it's a threat for even big tech companies. Okay, with all the bird variants that we see, with all this GPT-3, the transformers, the T5, all of them are now threatened by this. Okay, so we are inflating our models without us knowing because of this situation. Okay, so that's why you have to worry about this, because it's impacting actually everyone. It's impacting you as a developer, it's impacting you as a data scientist. Same way. Questions about this?
Yeah, what would be like the best solution? So I know we kind of talked about the refactoring, obviously the code that some developers that hasn't that is like the stress.
Okay.
What do you think would be the best option in that case?
That's what we're working on right now. If you have a good idea, let me know. That's exactly what we're trying to solve right now. See, I'm now switching off the presentation. I'm now being a professor, right? This is how you attract your audience. If you sell the problem to them, they accept any solution right now. See, I've been spending all this time motivating this problem. And now you're like, man, yeah, this is an issue. How do we do that now? That's why from now on, you should keep in mind, you're expert in a problem, not in a solution. The problem is more important than the solution. Okay? When I ask students when they do their capstone or thesis or their class project, tell me about what you do. Yeah, I'm training this model for the purpose of, no. This is the other way around. You tell me what makes the problem interesting, and then you tell me how you're trying to solve that. So from now on, don't start with, I'm using this deep learning model for the purpose of, but instead say, this is a problem. Look at how it is impacting people. Let's do something about it. And then you can tell me anything you want. I'll be okay with that. Okay? And see, it's impacting everyone. Okay? So that's what we're doing right now. And that's how you can attract, this is how I can attract, this is how Lee can attract people like JetBrains to work with us. Because we tell them, hey, look, we have a problem here. And they say, yes, let's do this. Okay? So when you have an idea that can actually help with this, everyone will listen to you. Okay? So our idea was to find a way to actually anticipate, right? And figure out this part, right? This part, whenever we have fragments that contain the same logic, when it's actually happening, let us right away say, hey, refactor this instead. It's when the action is happening is the best time to recommend refactoring. Okay, because once the code is there, the harm is done. That's it. But when someone is copy pasting their code, right? If we tell them, hey, you can do this better in that moment, we win. That was our solution. We can do better. You can come up with another solution. I'll take it. But our idea was the moment we start copy pasting the code, let us tell the developer right away, hey, you copy pasting code. Do you want to make this in a method instead? If they say yes, we win. If they say no, they have another reason. Maybe they're going to change the code later. That's okay. But at least we tried. Okay. So that was our solution, is to support developers with better copy pasting code by telling them right away to refactor it if it's possible, right? So what's going to happen is this. If someone copy paste this piece of code, which is fine, okay? They copy paste code, we can tell them, hey, there is an extract method refactoring is happening here. It will be like a small tooltip on their IDE that says, you have refactoring here, by the way. If they click on this, we can give them the IDE refactoring. So what we will do when they click here, we will call actually this button. We will go and click on this button and have all the things filled up for the developer, and then tell them just click on refactor. Okay. So what we did is from now on, when someone copy paste code, right? Like in this example, we will just have this refactoring ready for them. So we will prepare, if they click on this and click on yes, I can want to refactor this, right? we will have this into a method that they can just rename and they move on. And then we'll replace all these copy paste, all these fragments that we will replace them right away with the method call instead. I think this is a better solution, right? So from now on, our solution is, is to do that, right? However, there is one single thing here. This is all good, okay? But however, not every copy and pasted code is perhaps worth refactoring. Okay, because maybe if you're kind of pasting a couple of lines, right? It's not really worth making a method out of it, right? But maybe if you're kind of pasting a code fragment that contains a lot of logic, something that you think it's worth putting into a method, right? Then we can show this tooltip. Because if we start showing this tooltip every single time someone copy pastes code, then they get annoyed and they no longer look at it. So the main challenge with us showing this recommendation is, when do we know whether this piece of code is worth refactoring or not? How do we know that? And this is a question for you guys. When do you see, how do you think that, what is your thought of something that should be stayed as is as a code, when you copy paste code, or something that has to become a method? How do you make a decision when you're writing your own code? How many times it's used? That's one point. That's good. How long it is, how complex it is, what is it doing exactly, right?
Might think ahead, like, is this something I might need in the future for something else, or is it exclusive
To this part,
to this specific task?
is it reusable, right? Is it reusable elsewhere that is worth reusing? So, but how do we know all that? That's the main problem. We don't. It's such a subjective thing with no clear answer that is really hard for us to come up with one answer. So as data scientists, what would you do? Wisdom of the crowd, supervised learning. If I have examples of people copy pasting code, then making a method, versus examples of people copy pasting code and not making a method, guess what I can do? Binary classification problem, right? So you see how the solution was born out of the problem, right? I don't know how to evaluate this, right? From now on, my problem is this, right? I have this piece of code being copy pasted. I have to come up with a solution that says, yes, extract it. It is worth refactoring, or no, just keep it as is. And this is for the purpose of not annoying the developer, because otherwise they will not listen to you anymore. So we have to make sure we only show that refactoring recommendation only when it is worth refactoring. And that is our main contribution in this project, is figuring out, as data scientists, as AI people, how do we make a decision in this point? How do you call this piece of code worth refactoring or not? The way that Lee here thought about is like, let's do this through machine learning. So what I can do is I can look at all the examples of people, the examples of code fragments that were refactored later into a method, right? And I have the example that were not refactored. So from now on, if I have a new example of copy paste, is this closer to these guys or to these guys? It's binary classification, right? So this is how this anti-copy paster project was born under this JetBrains thing that we are actually contributing to since January, right? Around January time, yeah. And what they have done to do this is a typical machine learning pipeline of course, data collection of. So how the plugin works is that when you have a new copy pasted code, they can detect that it's a copy paste, it's their part, right? And then they put this into a queue to see whether this piece of code is going to change or not. If it did not change, after some time, it means developer, they are actually copy pasting code and keeping it as is, So it's a duplicate, it's a clone, right? Then calculate the metrics, lines of code, like we said earlier, coupling, cohesion, complexity, number of operations, 78 different metrics, right? And then put them into a vector, and then make that vector make a decision whether this should be refactored or not. But this model that look at this vector of numbers has to be trained somewhere, right? This model will look at lines of code, coupling, complexity, cohesion, number of operations, number of attributes, number of if, and then and say, yeah, based on those numbers, yeah, this code fragment is close. Those numbers match kind of the same numbers of those who get refactored, versus no, those numbers are similar to the ones that they don't get refactored, right? So this model is making a decision based on numbers to say whether this is refactored or not. But we need to look at examples, right? So this is how we do these examples. We look at previously extracted code fragments versus those who were not extracted. Okay, and we have to train a model to learn the difference between them in terms of numbers. Maybe this model will learn that whenever we have a code fragment that has the lines of code more than 5 and coupling more than 2 and number of operands more than 3, then refactor. Otherwise, don't refactor. Does that make sense? So this is how we thought about this, guys. By the way, I'm here to also listen to your ideas. If you have a better way to do that, let me know. Let us know.
Yeah. It's open source, so
it's open source. It's open source, right? Mm-hmm.
I'm curious, when you're reading the data, are you just looking at it as like just the raw text of it, or are you parsing? So like if you're talking about Java, for example,
Yeah.
are you parsing it through a Java compiler and keeping track of, okay, this is the particular type token, this is the variable name token, this is the operation, or whichever.
Perfect, excellent question. When we take this code fragment, it's actually Java code, by the way. This is all Java. We have not done this for Python yet. This is pure Java. So IntelliJ, they have their own code representation, like the abstract syntax tree, right? They call it the PSI, which is it's like the equivalent of the abstract syntax tree. And through that PSI, we look at all these tokens, correct? Okay. Yeah. And this is how we calculate those 78 metrics through their own API. That's how they contribute to this project, by the way. This is their work.
Oh, so IntelliJ already has this.
Already. Yep.
Okay, that's very useful.
Yes, very useful indeed. So we use that IntelliJ internal framework. I mean, of course, this part was done by JetBrains, so they're IntelliJ people, right? They know what they did, right? So they were using that internal representation to calculate all these metrics.
Those 78 metrics, are they all mechanical design?
Yeah. And we're looking for making them better, improving them. Because with the rise of language models, maybe we can no longer represent code through metrics, right? We can just use the code itself. Maybe. Okay. We can look at the source code itself instead of having something that represents the code, which is the metrics. Can we do something more with the code itself, right? Is that possible? The answer is maybe, right? So that's why this also can be extended. But at this level, our specific task was this. This is all JetBrains guys working on this, right? And this is us. Okay, you can recognize me and Lee, but back then we used to wear masks, right? That was last semester. Okay, so they will they tell us, can you do a better job with this model? We have our own model, but can you do a better job? And Lee here, yeah, he did that. So this is how you can actually find something useful for your capstone, right? Something concrete, and you can contribute to it through your own, class project, capstone, thesis, and then push this into GitHub, right? So because usually students, they come to me and ask me, how do I know what should I do, right? This is an example. it's a good example because it's a good and hard example at the same time, because you're dealing with the real real situation, right? This is, I mean, when you push this code to this repo, people will look at this and see whether you did a good job or not, right? And they get back to you with your feedback. They get back to you with feedback, right? But if you do that extra mile and you take your class project or you take your capstone seriously by giving it enough time, you can convince them to adopt your model. And that's what Lee obviously has done. As simple as that, right? It's your own decision to treat your own code that you write for a class project or capstone to be something you're proud, you can become proud of or not. It's your decision, by the way. Yes, you can do this to get graded on it, which is fine, but you can do better than that and have it become one line in your resume. It's your own decision, guys.
Would this now be like, is it in intelligent?
We'll get to that.
Yeah.
We'll get there.
We'll get to that. So this is, yeah. So do you want to have the video right now, or
Yeah, we can get the video, right?
you can do the video? Sure. So let's show you how the video works. This is the video of the plugin.
I don't think I piped the audio through the room, so I'm gonna have to play it through my computer, but I can go back through the video and then describe it in my own words after it's done playing.
Let's imagine that we are writing code in the project, and as it often happens, we now need to copy and paste some code into a new method. We go to the necessary method, we select the code, copy it, and then paste it. As soon as the code fragment is pasted, the plugin puts it into a queue. Since in this case we're not editing the code fragment, after the delay the duplicate remains, so all the metrics for this fragment are calculated and the embedded model makes a decision. In this particular case, the code fragment is rather simple and the model does not suggest to extract it. Now, let's say we need to copy and paste a larger fragment. Once again, the plugin waits for a short period of time after pasting, checks that the duplicates are still present, calculates the metrics, and runs the fragment through a model. In this case, the model decided that the fragment should be extracted, so the user can see a notification in the bottom right corner. When the user clicks the notification, the plugin demonstrates a message that this code fragment can be extracted into a separate method to simplify the logic of the enclosing method. The plugin has several such messages that are based on the metrics of the fragment. If the user agrees and clicks OK, the plugin takes them straight to the built-in refactoring feature. Here, the user can name the new method, select its parameters, and carry out the refactoring. Then, they can replace all the duplicates with the calls to the new method. This way, the code duplicate was removed during the writing of the code, without the need for a separate refactoring session later. However, developers often copy and paste code just to edit it. This is precisely why the plugin implements the delay before processing the fragment. In this case, we are editing the fragment shortly after we paste it, so the plugin will not find duplicates after the delay and therefore will not suggest anything to the user. This allows us to avoid annoying false positive suggestion every time some copy and paste is made to edit the code. You can find the source code of the plugin by following this QR code. Thank you very much for your attention.
Yeah, so what we saw here was, how this plugin works, where you copy and paste your code. It takes the metrics, feeds those metrics into the model, which will then decide, okay, is this a code fragment that's worth refactoring or not? Obviously, we don't want to be too overactive on that, otherwise they'll get annoying and the person will be uninstalled, like they don't want to see it again. And also there is a slight delay to allow you to copy and paste and edit. So right now we're only looking at exact duplicates. But if you do copy and paste, significant code and the metrics, turn out right, then the model will be like, hey, this will have to be refactored. So I want to go into, as a data scientist, how I was plugged into this problem where they're like, here's the, overall problem. Here's our data. We need you to come up with a solution. Like, because there's there's a middleman in here. We have all this data on which I'll go through actually. So let me get back to the slideshow. So first, we need to collect data, right? We need to decide, okay, what are we going to train this model on? So what we decided to do was we took, I think it was like 13 large Apache Foundation projects. And we found like where developers in the Apache Foundation decided to extract or not extract code. So now we're kind of making like this like cognitive like basis of like when did people actually make this decision? So we're kind of training a model on like people's decisions so it can better serve a user because we want it to kind of behave as a person would. So we used refactoring miner and we basically saw, okay, these were, a set of refactored, duplicates. These were a set of duplicates that weren't refactored. And now we have a positive and negative class. So now that when you have that data, how do you actually go about, training some model? So here, they gave us the kind of overall like plugin pipeline, but now we have our input of, this data that was either refactored or not refactored. We need to have some model that will then output, what should we extract this? Should we not extract this? And whatever that outputs, we should tell the user or not tell the user. So because you're AI club, I went and I made a side presentation to really dig into how this model works because that's what you guys are interested in. You aren't like a general audience, or if I throw this at you, you're not going to be scared of what this is. So yeah, you can still be a little scared. So first of all, we have a binary classification problem. So there's 78 metrics. Here's like a snapshot of what these metrics look like. Then we can take these metrics, put it into some type of input vector, and then we have labels because we looked in to see what developers did. So given this set of code metrics, did developers tend to refactor or did developers tend not to refactor? So what I chose to do was I chose to use a one-dimensional convolutional neural network to do this binary classification. CNNs are commonly seen in like image recognition, but they're also very well fit to look at a large dimensional space and kind of distill the information we want from it. So the network architecture, if you guys don't know, which I assume most of you know, what a CNN does is it basically we're taking this vector of inputs, then we're sliding a series of filters on it. These filters are basically just like weighted values. So like in this example image, like let's say this is our input image, and what we're doing is we're sliding like this filter, which is this binary weights of 1 and 0. So 1 catches 1, multiplies by 1, and then projects on to the next feature map, which then you can then repeat this process until you kind of like get to your final, like, is this a 1 or 0, your binary classification. And the thing it's learning is how to adjust the weights inside of this filter to get the optimal like information from the input all the way to output. So if we go into this, this is a very interesting architecture because what we do is we take our input layer, like our input 78 metrics, we do a batch normalize. So, because our metrics are of different orders of magnitude, like symbols per line is going to be greater than area, like in this example. But we don't want the model to learn that just because it's bigger, it's more important. So you need to normalize these values between, I think batch normalize is between like -1 and 1. So they're all kind of on the same playing field because that we don't want to learn like superfluous information. So we batch norm, and then we immediately do a deconvolution into a convolution. And if you look into a lot of networks and architectures used for signal processing, you'll actually see this a lot. So if you ask like electrical engineers or something, like what kind of CNNs do you use? And then you look at their architecture, you'll see they'll do a deconvolution, which is actually taking your feature space and kind of shrinking it down. So instead of like taking, you're basically taking your filters and making them kind of like average or kind of like take multiple values and sum them up into one cell. So we go from like 78 like initial metrics, then we go down to like 32, but then we immediately convolute after that, which is kind of like projecting the feature space up again. So this deconvolution followed by a convolution is kind of acts like a filter where the deconvolution is going to distill the 78 values into the most important like 32. And then once we have the important 32 values, we're kind of upscaling or like increasing, like signal boosting those values to it. And then we have some max pooling, which is basically just taking the max value out of each cell in the convolutional feature map, which further kind of distills down the most important values. Then we have dropout, which isn't really a layer. It's like a anti overfitting type of thing, where we don't let all the nodes look at all the data all the time. So some of the network is kind of blind to some of the data, so it can't overfit it. And then finally, we have a dense layer, which is kind of like the classical neural networks layers. That is just kind of like a linear equation where you manipulate the weights to kind of match your output. So, and then we'll get the final output out of the results of the dense layer. So if you kind of break down what this network is doing, is this kind of deconvolutional, convolutional pool like section is kind of like our filter. We're distilling from our 78 metrics, what's the most important information out of that. And then finally, after we filter out the most important information, the dense layer is really the thing doing the learning here. It's actually learning how do you correlate this filtered data into a final binary classification. And then we did some feature selection, but we found that all 78 features were somewhat impactful on the accuracy of the model. So basically how you do feature selection is you can either remove or shuffle one of the features at a time, like going through all 78, and then retrain the model and see how it affects the accuracy. So there are some features that had more importance than others, where our importance is basically we just inverted like kind of the hit to accuracy we were getting after. But they all kind of had some effect on it in some way. So we couldn't remove any features. We kept all 78. And then we actually used other classifiers as well. So this is comparing against random forest, SVM, naive Bayes, logistic regression. And as you can see, some of them, especially random forest, are actually pretty comparable in performance to CNN. So even though we have competing models, why do you think the CNN won out in the end? Any ideas?
Got it, like more weights, so like more parameters.
But that's only for training, right? Because once we have a trained model, well, why does this matter? Exactly, because we're doing a real-time calculation, right? This is baked into an IDE now. So if you throw in 78, parameters into a model, you want to evaluate in some fraction of a second, right? And so once you have a trained CNN, all the weights are, fixed, doing a forward pass through it is actually very efficient because it's just a bunch of multiplying and adding. When you have random forest, you can, if you know how random forest works, right, you're throwing a, value through a bunch of decision trees. Decision trees themselves are slow because they're a bunch of if-then statements. If you have ever done like assembly or something, like, how memory works, how if statements work, they're actually very computationally intensive. And now you have a random forest, which is many, of these trees. So it's not a model that's going to work for you in real time as well as a CNN is going to, even if it has comparable performance. So when you're thinking of deploying a model to anything real time, you got to think actually now, when I use this, is this going to be slow or not? And let's see, that's the usefulness survey, but I'm going to move on actually to a demo. This is kind of going to be just a little slice of how this problem was solved. So you can take these skills and like what I learned and apply them to your own problems.
So before you start that, so
yes.
I want to just reflect again on the size, because that was one of the challenges that we had with it. Right? When you first gave them the model, they're like, there's no way in hell this is going to be in that. Look,
Yeah.
and this is where you realize that as a student, you always think that everything is a lot. And that's how we are always driven by performance of model, right? But at some point of time, you have to hit the ground. That's when we realized that, okay, even random forest, because they had random forest back then, and they knew it was very expensive. So they had to prune that. something. And when they prune their own decision tree, right, they end up losing a lot of performance, but this is the best they can. Until we came and said, hey, we can give you another solution. We keep the performance as is, but also this is a cheaper solution than this. Okay. Yet, the whole plugin is 150 megabytes right now. 10 megabytes is all the other plugins, and 140 is our one. It is still
Yeah.
not as, even in terms of size in the megabyte, it's a huge. But this is because of sensor the dependencies. But again, to show you that whatever you think that your component might be as small as it doesn't mean that it might not be the one that is becoming the bottleneck.
That's right. Originally, like if you like export a CNN from, we use TensorFlow. It's a really small file because it's just gives you the weights basically in like edges, saves as a network. So like, oh, this is only like some fraction of a megabyte. This is going to be so good when we plug it in. But it turns out all the things you need to like mesh like a TensorFlow object into like Java is like 140 megabytes of like packing basically to make those two things talk to each other. So that's also another thing. If you know how to do that more efficiently, go talk to JetBrains. They'll like to know. So even though originally we thought this was going to be a more lightweight model, it kind of was like on par with the random forest in the end in terms of memory size, but it's still faster in terms of time. Yeah. So now I'll move on, and I have a little bit of a tutorial to show you guys. I'm sure you're all interested in how to actually like, solve this problem if you want to solve it on your own. So first, I have a little GitHub link here. If you want, you can ask me, and you can set up an environment. We have all of our, classic in data science. These are like your classic all-star players for packages. You see them everywhere. So first, we need to load our data, which here I have. So it runs faster and it's easier to train. I gave a subsample of the actual data we worked with. But here we can see all of our metrics. So we have our total lines of code, total symbols, and all these 78 features. And it ends up in a label, which is going to be 0, 1, depending on did they or did they not refactor it. So that's your binary label plus all of your features. So the first thing we need to address is there was actually large class imbalance in our data, which means that based off of the code fragments we saw, most people decided not to refactor rather than refactor. And then this is a problem if you're trying to train some type of machine learning model, because it's going to overlearn the negative class and kind of forget about the positive class. So if you don't do anything to this, train a model and just run it, run your accuracy metrics, you're like, oh, we got 99% accuracy. That's because 99% of the data is negative. It's going to say 100% of the time, don't refactor. And then it's going to be like, oh, you did so well, like it's so accurate, but it's completely useless. So first thing you do is you balance your classes out. So now you have 50-50 representation between positive and negative. So it'll actually learn a fair representation of when to make the decision. And after that, you can do some data processing, like we said. In the actual implementation, we use a batch norm layer, but if you want to do it yourself, you can like use some standard scaling. Basically what I said before, where our metrics are of different orders of magnitude, which you don't want your model just to learn that bigger numbers are like better. You want it to be an equal playing field between all the features. And after it's processed, do a little reshaping, and then we can create our model. I already walked through the architecture, but I gave you all the tools to build your own neural network inside of Python. So here I imported all the layers you need, and here TensorFlow is very kind of intuitive, where you can just kind of like stack layers on top of it. So you can keep adding filters, you can add like max pool layers, you can add dropout, build whatever architecture you want, or run your own algorithm to like do an architecture search. And then after this, you've built it, you can compile it, run it on your data, and this CNN will now learn it. So we can see every epoch or every time we cycle through the data and adjust our weights, it's learning, like the accuracy is increasing, precision is increasing, recall is increasing. And after that, you need to actually evaluate how well your model did. You can just say, okay, we did train test split. Now we, ran this on the testing data. It did, this well, and that's the performance. But there are better and smarter ways to actually, get model performance than doing that. So what we decided to do was we used a k-folds cross validation. So for the sake of time, I think this is just a 5-fold cross validation. What k-folds basically is you take your entire data set, you split it up into like k partitions, and then you use like k-1 partitions to train the data, and then 1 to test it. And you keep cycling through which is the testing and which is the training data. So now you're basically testing, is my model actually overfitting the data by seeing if it sees different portions of it, will it perform the same? And so after doing this k-fold, we can plot out its performance over like each partition of data it saw. And we can see that there is a bit of variance within, how the data performs depending on which of the 4 partitions of data it saw versus which one it tested on, which means there is some slight overfitting going on, because if it sees different data within our entire data set, it's going to perform differently. So it's kind of hanging on to certain things more than others. So it's really more honest to kind of give the average of your k-folds and say on average it will perform like this. And that's kind of the entire machine learning pipeline in brief. And I hope you can take this knowledge and use it to solve your own problems. And yeah, I'm pretty sure that concludes our presentation. Are there any comments, questions? Want to explore this anymore? Yes.
Sorry if you went over this at the beginning. I came in a little late, but I was curious how you got involved with working on this. Yeah, how this whole thing came about.
So this, for my end of it, as the data science being plugged into this, problem, this would start out as a class project when I was in software engineering for data science, right? So it just turned out to be this class project, and I was like, okay, every class has a project, so I'm gonna go and take a stab at it. And I ended up finding the best solution anyone has found for this particular model. So it was kind of like, my beautiful mind moment, where like I didn't know this was like an unsolved problem until like I did it, and like, oh, here's the solution, and they're like, oh wait, you beat everyone else's solution. And then it turned into getting into meetings with JetBrains, and then it turned into writing a paper, then it turned into going to a conference and giving talks, and now we're kind of on the speaking tour, kind of letting everyone know the work we've done. This is open source. We're still recruiting talent to work on this, and right now it's like in open beta as well. So we have a survey and a chance to actually like use the plugin yourself. If you want to be kind of like part of the beta development process, please talk to us. We can set you up with this tool so you can use it on your own and see how it works for you, so we can keep improving it. Yeah. So class projects, don't sleep on them. They could in this case, this project also landed me a job for when I graduate, but and it took me to conferences, got my name on a paper, so it's been a good journey. Yes.
How much feedback have you gotten from actually users using the plugin?
Yeah, this is, I think I ended here. Yeah. So we had an initial survey that we gave to developers using this, right? So we took the 5 little bubbles you see on every problem, every survey, on like the tool setup, the tool documentation, the ease of use, execution time, and amount of pop-up notifications. So for most of our metrics, they're either like neutral to somewhat to very satisfied, especially with the ease of use. We found that was the biggest problem, like when we were going through the background, where people didn't refactor because they didn't want to click on the menu and then click the refactoring button and then click the right refactoring. Well, now this is just a pop-up where you click one button, give it a name of a new function, and it does it for you. So we're hoping now that this is refactoring code is going to be a very like easy thing to do, more people are going to do it, because people are lazy, but we're kind of catering to them now. We're like spoon feeding you the refactoring you should do. And
So, but if you think about it, by the way, I mean, not
Yeah.
to discourage, but also if you want to look at it from a different angle, this is not linked to the model. This is not linked to the model. This is linked to the model. This is somehow linked to the model also, yes, linked, and this one is linked. So the ones that are not linked are having a better acceptance versus model. This is purely the model because the model decides whether to show that modification or not. We have the least satisfaction. Is that a problem with the model? Not necessarily, but because it's a subjective problem, right? You may actually like what this is showing you or not. You can
for
make,
for this one, did you specify whether you're asking about too many or too few notifications?
we did not specify that, so
Okay,
we
because
don't know.
that'd be interesting if people wanted
Yeah.
to see it more or less.
Or less,
Yeah.
we don't know that.
Yeah.
So, but that's where you can improve. By the way, you can make your model to be more picky, obviously with precision, right? Or you can make it more, showing more notifications. So if you make it more picky, you're showing less notifications, obviously. Because you only want to show this when you're 100% sure that this is the kind of good fragment that everyone would refactor, right? So you're making it very picky, more precision, less recall, right? Or you can make it more towards recall and make it show up more often. Whenever there is something that is looks like people will refactor, you can just show that, right? We have not yet done something that can tune such model in between, right? So right now we have it just there.
Yes, I just want to chip in too. I know we're running a little bit late on time too, but so for people that haven't checked in yet, I can check in right here. And then Lee, would you mind, you can post the slides on the Discord if you can? Don't worry,
Yeah,
it's
yeah.
confidential.
No, it's not. This is open source. So I can post these slides and also I can post if people want to participate in our like open beta right now. There's a survey link you follow where we have a pre and post survey where before you use the model, we're going to ask you about your programming backgrounds and like kind of just get user statistics. Then you'll get sent to a link that will let you install this plugin. And then after you use it for about a week or however long you want to use it, you can take a post survey and tell us like how it performed for you. So yeah.
Plus, if you like this work, contribute to it, it's open source.
Yeah, anyone who needs a senior project, he has a group working on it right now. So, if you like what you saw here, there's we're recruiting, right? Yeah.
Having people interested,
Yeah.
you can be part of this work.
You guys been here before, so let's give them another round of applause. You got 3 leads. Yeah.